Welcome everyone. It's time to do Leetcode, and today's problem is problem 49, group anagrams. And this is one of the problems within the blind 75 list. So the description says we're given an array of strings, okay? And we have to group the anagrams together, and we can return the answers in any order. Okay, so the definition of the anagram you already may know, but let's revise it one more time. An anagram is a word or phrase formed by rearranging the letters of a different word or phrase, typically using the original letters exactly once. So basically, if you say say dog, right, and God, these two are anagrams because as you can see, these two words are actually made of rearranging the same letters, right? So typically an anagram is the words that has the same frequency of the same letters, or the words that are made up of the same letters. Okay, so we are given a list of strings. For example, you can see this is the given list of strings, and we have to group the anagrams together. So as you can see, eat, T, right? And 8. They have the same three letters, E, A, and T. So we have to group them together in the result. Similarly, nat and tan, right? These two has the same letters, A, N, and T. So they have to be grouped together. And then bat, that's the only word. There is no other word made up of A, B, T, so it's separate. So we have to return this as three separate lists, obviously. And they're grouped together. Or if it's an empty string, then we have to output empty. And if it's say just one string, obviously there will be just one group. Okay, so how do I do this? So as you can realize, one way is what about counting the letters in each word, somehow tracking it, right? Obviously, that's a very good idea. Or what we can do is, what if we say sort the letters? If we sort the letters, then they should look the same, right? Okay, so for example, let's say these are the words, eat, then tan, right? Sorry, T8. Okay, so T8, right? What if we sort them? If we sort them, okay, so what we can do is, how do we keep track of all the groups? So what if we put a map? Say we put a map here. So the key for this is the pattern, right? And the value is the list. So say eat, if we sort the letters, it will be AET, right? This will be AET. So what we are going to do is, we are going to check if AET is already in the map. So this is the hash map. It's not. So what we do is, we put AET and we start a list here. And we say like EAT is the word that we have with this pattern, right? These letters. Okay, next for tan, if we sort the letters, it will be ANT. So ANT is not still here. So we put the pattern ANT and start a list and say TAN is a word which actually has this pattern. Then we sort the letters for T is AET again. And as you can see, we already have AET. So that means T goes here, right? 8, again it's AET after sorting. And as you can see, we have this pattern AET. So 8 also goes here, right? So now you see that once we sort the letters, they now will have the same sequence of letters and they will have the same pattern. And that way we can identify the patterns and put them in the same list as values. And finally, what we are going to do is we have to return this list, right? Okay, so what is the time complexity of this algorithm? As you know, sorting takes order of. So if the length of the strings, say highest length of the strings is k. If that is the case, then the sorting takes order of k log k, right? And then there are n words, n input words. So in total, it's going to be order of n k log k, right? So this is the time complexity of this algorithm. This is the time complexity of the algorithm. And how much space we need? So this is the space, right? So there goes the time. And this is the space. How much space we need? We need to store all the words, right? Okay, so the space is going to be, so if the highest length of a word is k and there are n words, in total, the space we need in the map is nk. That's the space complexity. Now, let's talk about the second way, the one that is even more intuitive, counting the words. But counting the characters. But if we count the characters, the question is, how do we create a pattern? Let's talk about it. Okay, so if I count the characters, this is something that you obviously have to um, ask the interviewer that what kind of characters are in the input. So if he says like there's just for this example is only lowercase characters, so we can say that the index goes from 0 to 25, right? Where index 0 represents A and index 25 represents Z, right? Okay, so then we'll have other letters, say, so we have, say, for E, right? A, B, C, D, E, this is for E, and then we will have something, an index for, say, T, right? And then we will have something for N, okay, something like that. Okay, so what we will do is for each word, we will count the number of characters. So you see that there will be one A, one E here, and one T, right? So that is the thing here. And then for this one, we'll have one A, one N, and one T. Okay, now how do I create a pattern out of this? Well, there are some characters that are missing. So we just cannot say, if I want to create a pattern like 111, that's not going to work. This one will also look like 111, right? So there should be separator between and the other thing is, say, if someone has in a word, someone has like A 1 times and B 11 times, right? Suppose a word like this, something like this, okay? Then you cannot just create a pattern like 111. And then another one which has A 11 times and one B 1 time. In that case, you cannot make the same pattern 111. You have to make a difference. So for that, why don't we use a delimiter, right? Let's do use a delimiter. So how this one will look is for each frequency, after that we will put, say, a delimiter. Let's put hash character. And then for the second one, there is nothing, so only hash. For the third one, nothing, so no. So this is for A, this is for B, this is for C, this is for D, and for E. So this is for E, right? And then something, and there'll be a lot of other hash. And finally, there will be another one, right? Okay, so then in the map, we'll check for this pattern. So in this map, we'll check if the pattern already exists. If it's not, then we put the pattern here. So this is the pattern. and then we put it, right? Similarly, as you can see for T, right? This will have the exact same pattern because the frequency count is going to be the same, 1, 1, and then T1, right? So it will exactly have the same pattern here, and this will check for the key here and put T here, right? Okay, so that means the second way is counting the words. So counting the words, how much time it will take. We have to first count the words and then uh, append them to make a pattern. So counting the word takes order of k. If the length of the words are k, right? This is order of k. And then appending them also takes order of k. The reason is for each character we append once, right? So if we use a string builder, that is also order of k. Okay, so then we have like n of these characters. So in total, the time is going to be order of nk. Okay, so now the time complexity is even a bit better. And the final thing is that for the space, we have to use the same hash map, right? So we have to use the same hash map here and the same amount of space, right? So the space is going to be order of nk. Okay, so if we count, it's even a little bit better than sorting the words. So I hope you understood the logic. Okay, so let's look at the code. We'll have a hash map, and the hash map, as you can see, the key is a string, that is a pattern string, and the value is a list of strings. So we'll create lists for against each pattern or create groups. So this one actually will represent one group, right? Okay, and then for a counter, since there are only small case letters, we will have a integer array of size 26. Initially, we'll fill up the array with count 0. Okay, so for the, yeah, so we have to fill up with count 0, and then or we can do it inside. Okay. And then what we are going to do is we'll read each string from the input, uh, fill the counter with 0, and then initialize a string builder. Count from this string, we'll convert the string into a character array and count the number of characters. So as you can see, if the character is C, if we subtract A from it, we'll get the index. And for in that index, we'll increase the value by 1. This way, we are increasing the count for that character. So after we count all the characters, next we are going to append them to make a pattern. So we'll just go through this array and say append the value, right? So we could have appended, so we could append just in the other order. So we could just put I here and then it's up to us. Okay. And then after that, the pattern, after creating the whole pattern, we'll convert this into a string, and we'll check if the pattern is already in the hash map. If it's not, we'll put the pattern in the hash map and create a new list. Okay. Or if it's already, if the pattern is already there, then it's fine. Anyways, we have a new list and we'll add the current string that we're reading against the pattern that we created. We'll add to the list in the map. Finally, we'll have different lists. So we'll create one array list of lists. So this is, so say this is one list created. This is another list. This is another list. 3 lists were created. So finally, we return one list of these 3 lists. Okay, so that's it. Thank you very much for watching, and we'll come back with another problem next time.